All right. I want to welcome all of you to our Polar Connect event. We're really excited to be talking with teacher Amber Lancaster and the team with the Larissa Project. They're someplace out in the Weddell Sea near Antarctica, and today is April 9th, 2012, if you're in North America anyway. And in the next hour, we're going to learn more about what Amber and the science team on the ship have been doing over the last 3 or 4 weeks, and hear more about what it's like to be working on a ship down near Antarctica. But before we get going, a few things we need to tell you about the platform we're using today. First off, Amber and the team are on a ship and their communications are limited. They are calling in by a satellite phone, so chances are that they will disconnect and reconnect with us a couple of times. So we may not know when Amber and the team drop off, but we'll try to get them connected with you as soon as possible. You will not be seeing any video of them or their pictures because of the communications. However, they do have the same slides that you are seeing, which should be changing in the center of your screen. And as we go along, we will relay questions in the chat room, which is to the left. And you can type in your question, hit enter, or if you have any other things you want to have us relay, we'll relay those to the team. At the very end, we'll also have an opportunity for those of you to ask your questions live. If you have a question that you do want to ask live or something comes up along the way, you can click the little hand icon that's above the list of participants. That raises your hand. It lets us know that you have a question. When it does come time for you to talk and ask your question live, you need to click on the talk button, click it once to open the talk microphone, and click it again when you're done so that you don't get feedback in your system. If you're calling in by phone, you can press *6 to mute your phone and *6 to unmute it. This event is being archived, and we'll send out a link afterwards and post it on the website. And again, if you have a question during the presentation, you can type it in the chat box. We will relay it to Amber and the team, and then at the end we'll have time for open live questions. So with that, we're going to go to participant introductions. We won't do those live today. What do you think? No. Yeah, we won't do those live today because there's a number of you and we aren't sure how long the connection is going to last. So if you would please do so, type in the chat box where you are from, and if you're with students, what school and how many students you got, and then that way we'll have a record of who joined us today. Before I turn this over to Amber, real quickly, the reason why she's down in Antarctica is she's part of the Polar Trek program. Polar Trek is a national science-funded project where we place teachers with researchers and so that they can get hands-on science experiences. Amber, your mom and dad say hello, and they also just typed in the chat to let us all know where they're from. So with that, I think we're ready to go. I'm going to turn this over to you, Amber, and we're on your first slide. Just cue us when you need to switch slides.
We get 3. Hey, Amber, you got 2 schools that just said hi. Mark Paricio is with his students in Colorado, and you have 18 of your marine biology students.
Great. Hi, everybody. I'm here with the Larissa Project, and Larissa stands for the Larsen Ice Shelf System Antarctica.
Oops.
Where there's a lot of different types of scientists on the crew because they're studying many different aspects of the physical and biological conditions of the environment down here and how it's changing as ice shelves have been collapsing. So before I go anywhere else, if you could go to the next slide, I'm going to have each of the people who are with me say hello and tell us where they're from, what research institution they're with, and what their main area of study is. And so I'm going to turn this over to Maria.
Hi everyone. My name is Maria and I work as a phytoplankton ecologist in the University of California, San Diego in California.
Hi, this is Bruce Huber. I'm a physical oceanographer at the Lamont Doherty Earth Institute of Columbia University.
Hi, this is Amy Leventer. I teach at Colgate University, and I'm a marine geologist.
Great. So if you could go to the next slide. This is a fun picture of me holding a giant sea cucumber that we pulled out from the bottom of the seafloor a couple of weeks ago. And so it's one of my favorite pictures of the trip so far. All right. Can everybody hear us still?
Yeah, you're doing a great job, Ann.
So on to the next slide. I want to introduce you to the boat that we're on. This is the Nathaniel B. Palmer.
Oh, Amber, are you still there?
Yeah, we're still here. Can you hear us?
Yeah, you do cut in and out every once in a while, so we lose a few words, but I think you're okay. I think we'll do good.
All right, just let us know if we disappear, because we won't know otherwise. So this is a research vessel and also an icebreaker. It's almost 179 feet, which is almost the size of a football field. It's about 5 stories tall, and if you look at the front of it, you can see the ice tower, and that's the tallest part of the ship where you can climb up to the very top and see all of the ice that's around us. You can go to the next slide. This is a map of where we've been so far. So and we've gone through the of Magellan and then out into the Drake Passage. And the Drake Passage is where the Atlantic and Pacific Oceans come together. And then we went down into and around the Antarctic Peninsula. And so you can see we spent a lot of time, particularly in one area called research and exploring the area there. So that's where we've been so far, and we're slowly heading back up towards South America. We still have another week of research to go. All right, you can go to the next slide. So I'm going to talk a little bit about what it's like to live on a ship. This is my bedroom and my bathroom. You can see they're pretty small in places. It's pretty cramped. I share a room with another researcher on board, and she has the top bunk. That's my messy bunk on the bottom. And you can see that we have TVs and phones, and so you might think that we're able to see a lot of things. Get is information about what's going on, where we're at, what the wind speed is, and also views of different sides, different parts of the ship. So we only get video from on the ship itself. And the phones don't really call anywhere except other rooms on the boat. In order to call back to the United States, we have to get on a special phone that's a satellite phone in order to talk to anyone else. So I have a bathroom, and my bathroom also has a shower in it, so I'm able to take really hot showers whenever I want. But that's my little home. So you can go to the next slide. People always ask about the food. Our amazing chef who has been preparing us food. You can see we get soup every day. There's a salad. A couple things about the food, though. You can see that at one point on the ship we still had lettuce and pineapples and really delicious fresh food, but at this point we don't really have any of that anymore. We've been here long enough that we don't get to actually eat anything except for canned foods at this point, mostly because it just doesn't last for that long. The other thing to know is that we have 4 different shifts of eating, and so there's 3 meals during the day, and then there's another meal at midnight called mid-rats or mid-rations or midnight rations. And so people get up, because we're working 24 hours, there's groups that are on from noon to midnight, and then there's groups that are on from midnight to noon. And so there has to be food to feed everyone. So there's actually 4 times of the day that you can eat down in the alley. All right, next slide. This is a picture of some of the stuff that we do on board for fun. You can see there's a lounge with students who are watching a movie. There's the exercise room. Challenge, but kind of fun. And lately there's been a ginormous foosball tournament on board. It's been very competitive. There's been 16 teams playing, and this is just a shot from that tournament. In addition, we just recently had an Easter egg hunt on board, and last night there was a dance party in the lounge, so there's always something new and fun happening on board when people get off shift. You guys can go to the next slide.
Hey Amber, real quickly, since you had you were showing all the food, somebody wanted to know, how does Amber's vegetarian diet handle all the food options?
I've been doing vegetarian tea. In fact, I think there's about 3 or 4 vegetarians on board. It was a little better when we had fresh fruit and veggies, but I'm doing just fine. I made friends with the chef. I think that's the important thing to know. If you make friends with the chef, you always can eat. All right. Where are we on? Are we on my luggage picture?
That's correct.
All right, so this is just a picture I took at the very beginning of the trip. People always ask what to bring. I brought all these clothes and I haven't worn half of them because in actuality I end up wearing really warm clothing all the time. So if you go to the next picture, this is what I wear most of the time when I'm here because we're working on deck. You have to wear certain clothes, and so you have to wear these float coats, which are right over overboard. They'd be able to spot you and they'd keep you afloat, and they're really well insulated, so they keep you really warm. And then almost always they have a hard happening out on the boat. And so these are just kind of some of the things that I wear a lot of the time, just basically to keep warm. So some of the things that we've seen, if you go to the next slide, I just like to show people the ice that we've seen. There's 2 really big is the ice that forms from the water when it freezes, and then there's the type of ice that has broken off from glaciers. And so on the left side you can see sea ice and pancake ice. That's when the fresh water freezes on the surface of the sea, and eventually that pancake ice will get cold and those pieces will actually form together to create a solid layer of sea ice. And then the icebergs, which are really, really tall, you can tell they're icebergs because they're so large, that have come off of glaciers. So they've broken off and are floating in the sea itself. And then if you go to the next slide, I just want to share some of the beautiful creatures we've been able to see. Minke whales, that was right off the back of the boat as we were doing a mooring installation, which you'll hear about later. Dolphins, which we saw as we were still near Chile. Seals, and I saw some to have a whole bunch of emperor penguins come by, and we've seen a lot of different types of penguins and seals, but just to give you just a clue as to what we've been able to see. So with that, I'm going to turn it over to Bruce and have him introduce what he's talking about and some more about the ocean and ice interaction.
Thank you, Amber.
Okay, hi, this is Bruce. As I mentioned before, I'm a physical oceanographer. That means that I study the physics of ocean circulation, and one of our specialties with the group that I'm working with is the interaction of the ocean with the ice. In particular, we're interested in looking at ice shelves, which are floating glacial ice that actually floats on the surface of the seawater. It's fed by glaciers that come down from the continent and form a large layer that literally floats on top of the salt water of the ocean. In many parts of Antarctica, there are these floating ice shelves, and they sit on top of the ocean and interact with the ocean. They exchange heat and fresh water. The ocean is actually warm enough, even though it seems cold. It's minus 0.8 Celsius or about 28 degrees Fahrenheit. It's still warm enough to melt some of that ice. So there's some interesting processes that go on, one of which is that if the ocean gets warmer or we move more water under the ice shelf, it can actually melt. Ice shelves normally grow and shrink as this balance between glacial ice and ocean melting changes over the years. But in 2002, the Larsen B ice shelf, the one in the middle on the next slide, actually broke up into thousands of icebergs and drifted away. And we're very interested in trying to understand why that happened so suddenly, and also to try to understand what the impact of that sudden disappearance of the ice shelf was on the ocean, on the marine life that lives in the ocean, and on the marine life that lives on the bottom of the ocean that was once covered by this floating ice shelf. Okay, on the next slide, this is a schematic of all of the processes involved in that ocean ice shelf glacial balance and how they interact with the various forms of sea life and the atmosphere and the chemistry. It's a little complicated, but the thing to understand from this particular figure is that the ice shelf floats on the water actually flows under the ice shelf in one place and comes back out again. And what I'm particularly interested in is how that process occurs. How does that water flow underneath? What happens to the ice shelf when it comes in contact with the ocean? Does the ice shelf cool the ocean as it does in some parts of Antarctica, or does the ocean melt the ice shelf? So the next slide, in order to understand this balance, we also have to know what's happening with the glaciers that feed the ice shelf. And to do that, we have instruments installed on the continent called amigos. These measure the ice motion using GPS, like the GPS in your cars. They also have meteorological stations on them to measure winds, air temperature, radiation from the sun, and they also measure snowfall. One of the things that's important about understanding glaciers and ice shelves is how much snow falls on the top of the plateau that feeds the glaciers. More snow means more glaciers form, the glaciers move, and they move out onto the ice shelf. The next slide shows some of the instrumentation that we use on the ocean side of this process. On the left is an instrument called a CTD, which stands for Conductivity, Temperature, and Depth. One of the important things to understand about the ocean is the distribution of temperature and salt, what makes the ocean salty. These are not constant with depth or with position in the ocean, so we have this particular instrument that measures these electronically. It's lowered from the ship all the way to the bottom and all the way back. In addition to measuring the temperature and salinity, we also collect water samples in those gray bottles, which are snapped shut when we send a command when it's under the water. It brings the water back, and the biologists and the geochemists and the geologists draw water from those and analyze them in the laboratories for whole plankton samples and geochemical parameters. In addition to looking at the temperature, salinity, and collecting water, we can actually measure the water speed and direction at the same time using something called an ADCP. That stands for Acoustic Doppler Current Profiler, and if anybody has questions about that later, we can try to answer those for you. That's the instrument on the right. It has 4 discs on it, which are actually little transducers that send out pulses of sound and listen for echoes, and by timing when those echoes return, we can calculate how fast the water is moving and what direction it's moving in. Then one more set of instruments that we use on the next slide are oceanographic moorings. These are strings of instruments and funnels that you see there, are sediment traps for collecting particles and biological material that rain down through the ocean. There's a big weight at the bottom, which you can see on the left there. The string of instruments is held taut by floats that we put at the top, which you can see on the lower right. Floats, by the way, are glass balls. You'd think maybe that those were very fragile, but in fact they're quite sturdy. They're about ½ an inch thick, and they can withstand pressures down to 6,000 meters in the ocean bottom. We've put out 4 of those moorings so far, and we're going to come back next year and collect them, collect the samples from the sediment traps, and collect data from the instruments that we put on the moorings, like the one you see in the upper right. So I'm going to pass now to Amy.
Yeah, hold on a second, Bruce. Come back. We have a question for you. Somebody wants to know, how dangerous was setting the amigos?
Setting the amigos was done by a team of ice experts from University of Colorado last year, and it was quite ambitious and a little bit dangerous. They flew to their site in aircraft called Twin Otters, And they got there by first stopping off at a British base called Rothera on the other side of the peninsula, loading all of their gear into these Twin Otter aircraft and then flying up to the plateau and camping there for several days while they put up these Amigos. They enjoyed it a lot. They have a lot of fun, and we have great communications, and we always have backup safety plans. So it's not really that hazardous. But like anything else down here, you have to be very careful, and you do have to get a little bit of training and know what you're doing.
All right, great. Thank you very much, Bruce. We'll see if we have questions at the end for you.
Hi, this is Amy, and I represent a team of scientists whose contribution to Larissa is to look at the mud that you can see in the picture there. The sedimentary record to try to decipher the history of the Larsen ice shelves. We're looking at both the recent breakout that happened in 2002 and earlier, and then we're trying to look at others that might have occurred in the longer term past, over the past 10,000 years. And what we're trying to do is to figure out how stable or unstable are these ice shelves and how does their instability relate to changes that take place in climate. In the next slide, you can see some of the things that we are seeing do with abilities, essentially understanding the watch. And so I already know that on there is a navigational table, and they monitor the data that is collected with instruments. This includes Amy, Sarah, check them or check them with Josh right on that because people have found one down once again. Do we still have you there? Can you hear me? We can hear you, great. Okay, that sounds good. I just have to watch too much. Hold on a second. Can people hear Amy again, Sarah, can you say one more thing? We'll see if we can hear you. Okay, still garbled. This sounds polar tremble, so garbled. No, the sound of the polar tremble, is that better? Yeah, and the ones on the other end that are having trouble. So, how about in Bruce, you were pretty clear and with Andrew, without any you might have to really on the figure. So you're, can people hear me now? We can't hear you, but the participants find it audible at the moment, so it might be some satellite. We're not sure. All right. Are you having trouble with the you say whether in you say and all of us, including yes. Okay, on the phone, okay, so like that, I thank you for the last responding there. Just try to you're awake around as long as you can, and slowly, and maybe even louder than you normally would. Okay, I'm really slow, and you can starting with the students and watch. And these students are underway. So they keep track of our physical data. So we do electrical weather data. We do this every week. That's pretty clear. It was. At the very end, but people are just talking by the phone. Just keep going. All right. Okay, on the next slide, you can see that I made a floor, and what to help understand how the glaciers on the land has grown over time, and in this example, you can see some really deep areas where glaciers ground was much more ice here, and then we try to use those glaciers how change over time. We take samples from the bottom of the ocean, and the way that it is kind of like a history of the surface of the bottom of the ocean. Maybe possibly the water again, or deeper and deeper, and weaker in the core, and going farther and farther to find time. And so if you figure out the core longer and longer to be clear cords that are up to 80 feet long. And in that upper right, you can see the sign danger. And this cord was a weight of 11,000 pounds, and the wire that a lot of people under tension do that. Nobody wants to go outside. In the next slide, you can see the core, the top and core, and these have the shorter amount of time, and we said we were shipped. It takes about 12 hours to go all the different temples, or an hour later. The next slide that you see is we collect samples every year. We don't have any of them before is on different files, and we do a variety of different kinds of analysis on that. And the next slide is one of the things that we do. Any that we have in the system. And we do that, and the other thing is gravel there. These are carried by things out in the ocean, and when we look at this in the beginning of gravel, it tells us about the geology and all the on the peninsula. Another thing that we do with all of this here, look at the plant, which you see on the left, and the arrow you see on the right, it's on the forum. These are organisms in the ocean, and they tell us about the environment that they existed in at the time that they were in either a day or 100,000 years ago. And they tell us things like well, there are a lot of water, and that they lived was the temperature of the ocean warmer or colder at the time that they lived. And this kind of connection that we have is helpful us. And this is how we're kind of living in the ocean. And so that's what the biologists are doing. Hello, this is Maria. And I'm looking for biology on the cruise. When you understand how the animals have the areas to be covered by I should know that the water and it's exposed to the air and the sun. And we are working with the animals and water in the water. The ones that live above the ocean, and then the ones that live inside sediments. The same way that the ocean shows the clouds and forms in the sediments. The ones that were before, we look at the ones that are right now. Look at the next slide. Hello. We do just start joining by follow Maria, let me what to do. If you're joining by follow to otherwise you will get feedback. Star 6 that your phone. Star 6 done. Thank you. Press star 6 and I heard you ask that question. So, okay, go ahead, Maria. So I'm in slide number 99 on files and these the that ocean absorb the light and make up new carbon. That's similar to the on land that the fruit. But the main difference between the two is the water. You don't see them. They are very sparse. So the cold and we do that
like filtration in the middle of the site, and the plan is one water filter from there, we just need to have inside hydration proteins. And one of the things we do in the water, and usually the light in the carbon, and then you disappear and do it out into waters. And also, we don't have any other items, so if you look at everyone, people on the ship onto the ice, actually don't know, people are not because that's on the left. And then on the right, you see how we get the sea ice somewhere, or in that day, we have always the ice. For the people that are looking at the bottom of the ocean, they sample the core of the two, which is similar to the activity that showed up is a ring or tubes that are depositing the layer of the ocean and and they bring out the mud and the environment after the mud and the mud comes out. We also collect animals that's one and we call it four. It's basically a nest that is dragged follow the ocean, collecting animals and working and mud and then very names, and you can see how camera it's also pretty cold and wet, so everyone people on. Then another way is through photography, and in the number 4 on the left side, you can see how we call your camera. It's a protein that has a camera, and on the right you can split the camera takes looking down into the sediments and taking pictures of the trees so we can see I can show you a picture. Finally, there's another example, and that is shown as the 5. And for that, we put in the ocean that orange color to make us feel the rest. This is kind of a open bottle. They hang way somewhere where it's dying. They're both in the ocean, collect those balls and put them in this and release them in 1 or 2 years. And I like to eat them all, and like inside you can see the worms collected by the bones, and then those worms. And finally, someone on the ship, Syria. Hello. Stars on your phone. Murphy, are you still there? Yeah, I can hear you. Okay. I think we're back. Go ahead, Maria. Okay, so we're talking about number 36, in which the people that have microbes, bacteria, and also viruses, they live in a sediment where the alien strains, they pick up core, and they take like pieces of mud on the floor, and then they really inside the core, inside that sediment, and it could be which bacteria there are, or how many, so bacteria is the one that you use it until you die, or use other chemicals to live. Finally, in number 37, it shows some children on the black box. that is a big box where we see oxygen, nitrogen, and the reason to work with area that regularly under conditions because the oxygen is to them, so they need to work in an environment free of oxygen. And from the floor and blocks from the tubes, the right show everyone making measurements of activity in that environment. So the slide summarizes everything in line. It's a map. Very similar to the one shown with the table scale. We white points show stations where the separations lines underneath from 1 to 40. And each of these regions within the frame or the physics, I get things for the sediment and for I so I need sediment all those aspects. And then we put a map how the properties change space and time, and then answering the question on how the item has a sentient system and how the elements and plants are now using the element system. So if you have any questions, here, thank you. All right. So just letting them join. That's what they were good. They're not. So they have to phone there through connect for some reason satellite and working very well through our online platform. But if you have a question, you can look on the hand about the participant list and then you can ask your why the previous know what you're doing, so you can guard so you can unmute your phone, and that will be one way to do it, or you can just copy your computer. Okay, from Amber, so go ahead and state who you are, what your question is. So Amber, where the rig, and the amigo. Why are they as well as egos and for automated geophysics observing station? I have a feeling they came over the acronym to tell you the truth. But it does what they meant. All right. Thank you. Okay. We'll go to classes and like that to line. Click on the top button or unmute your phone. I bet you list. And I question from top one other and scary situations on the ship. Dangerous, yes. Okay. So go ahead and Amber, go ahead and answer the question live. No. Okay. I'm going to relay what they wrote. They would know what are the animals cannot be breathe oxygen, and it says from the glove box. Hey, Tracy, we can hear you, Christina. So if you hear the doctor, that would be great. All right, hello. Okay. We're going to like oxygen or like conditions in our area. And different from oxygen and make up carbon dioxide oxygen. These bacteria use like nitrate or methane. Other chemicals use the energy and make up carbon dioxide can make up, for example, nitrate. So if you know that this is any of the large toxic organisms that is called meaning resources that animals can't. Okay, right. So I carry from Masters would like to know are regular hospital and what can you do? All right, I'll talk a bit about work they've done. I haven't been able to go yet. We're able to go and explore find the environment Amy, and the cruise, the Another way that we can avoid going to ice immediately for those that are big enough to and want to ice people into the ice. And you spend a few hours making an ice core, a sea and bringing that ice into the studying there, and then studying there. Okay. Another thing, Sean, are you having, and what do you know about? I'm sorry, moment from home, and I'm teaching all students because I'm really really I've been on the phone and so we're on your computer there's every day, and so I'm able to make all my favorite green being able to cook. You guys. Wait, okay, it looks like I have another coming up here, so. And we're waiting for the question with you today. Can you tell us that? Coming on. Yes. Oh, I'm happy we have another week. And I could watch the world, I crank that because they the internet and America, I'm thinking of America, they're talking every day, and then it's ended up in more days to get back to their coach, so I know I'd be back. That's fully I'm going to drop on my time by April 3rd, so that's from the Right. So from your class of an OT, automobile, no sleds on the eye, go out. Let me of course, it's very beautiful. We don't need to bring them along, but oftentimes we find out here that heavy rain on the ice, snowmobile. You say snowmobile early on in the tow, something called penetrating radar across the ice dome. One thing I measure that's layer. They really enjoy that. They guys drive around for several days, knowing it will be behind the meeting. They tend to generally trying for the rest of us. We're out here on the ship, 24 hours we will be like on the ship. Okay, great. One more another question. Amber's medical live here. The node is moving negatively flexible. I heard important anyway. Not in the how the boat can go. And so, because icebreaker is designed to go through there are internal damages and it does how it different types of ice and how big the ice is. Okay, I'm trying to tell you sounds like I talked to you in person, so yes, I is the daily temperature outside like? Well, I think that it's about -18 degrees Celsius, roughly about 4 degrees Celsius. I don't know what it's really called. It was like literally none of us are more than 20 or 30 minutes having to go down by hand. But it's definitely colder and down here because we're in the southern hemisphere, and so it's gotten colder as we go further down, and we got Stay there. I'm clear. Okay, you cut out there. So you're only more minute, and another question. Brian, has anyone gotten sick? What is the process to get sick? And are there any doctors on board? Some research during to my training for that. There's a lot of medicine on board. A lot of it is doing the best that they can, and the people back in the States, there's a real problem where people need more help. But we've also been healthy. Not to go back over the drink, and that may not be really too well. Okay. Let's see. There's making sure that everyone has so Robert, man, we live next to you from 80 5 and her mom. Roberta, sorry about that. Oh, Roberta, sorry. Alright, so you're I this is JR. Can you hear me clearly?
Yes, go ahead.
All right, y'all. Go ahead. Thanks for signing up, sir. Have a good one. On site.